Hello ladies and gentlemen, this is Scientific Measurement and correlates with chapter 2.1 in your textbook. Here's your key vocabulary: metric system, international system of units or SI, mass, weight, volume, meniscus, and density. Please make sure you pay attention to the definitions of these words as we move through. It is traditional to measure a horse's height in hands. Nowadays, a hand equals 4 inches, but originally it was literally a person's hands. Here in the US, to measure distance, we use feet. At one time, you would use your actual foot to measure that. Henry I is said to have decreed that a yard should be the distance from the tip of a king's nose to his outstretched thumb. It's easy to see how this unstandard method of measurement could lead to problems with consistent measurements, since not everyone has the same size hand, foot, or distance between their nose and outstretched thumb. One solution to this problem was the metric system. This measurement system is based off a number of 10, so to move between different units you simply multiply or divide by 10. Having a standard system for science allows scientists around the world to collaborate on studies and communicate their results to allow others to replicate their work. Modern scientists use a version of the metric system called the Système International des Unités, or SI system, or in English, the International System of Units. The system is based on the metric system, but substitutes a few measurement systems that are better suited for calculating in science, such as Kelvin for temperature. Here are all the main measurements we'll be using this year. They are length, mass, volume for liquid, volume for a solid, time, and temperature. The base unit refers to the unit of measure without any prefixes on it. We'll discuss prefixes in another video. The SI unit is the most common measurement for everyday measuring. Almost all of the measurements except for one, the base unit and the SI unit, are the same. Be sure to pay attention and remember which one doesn't match this pattern. The SI unit of length is meter, abbreviation to M. Its base unit is also meter. To measure length, we use a meter stick, rulers, measuring tapes, and since many of you are used to yards, do note that meter sticks are a bit longer than a yardstick, so a 50-meter race is longer than a 50-yard race. Mass is the measurement of how much matter is in an object. The SI unit for mass is kilogram, which is good for measuring people, animals, cars, and other large objects. The base unit is gram. It is better suited for small objects like your cell phone and animals. This is the only one that is different between the base unit and the SI unit. We measure mass with things like a triple beam balance and a scale. It is important to note that mass and weight are not the same thing. Weight is the measure of the force of gravity acting on matter in an object and is measured in newtons in the SI system. So if I were to teleport you to the moon, your mass would be the same, but your weight would be less because the gravity on the moon is less than the gravity on Earth. We'll talk about this more in depth when we do our physics unit. The measure volume is the amount of space taken up by an object or substance. We have two different units for volume depending on the object. If the object is a liquid, we use liters as the SI unit. If the object is a solid, we use cubic meters as the SI unit. When you calculate length times width times height in math, you're calculating the solid volume of an object. To measure solid volumes, we use the same tools we do for length, then do a little calculating. To find the volume of liquids, we use things like a beaker, flasks, or graduated cylinders. One note on reading graduated cylinders. Due to cohesive and adhesive properties of water and other liquids, when looking at a graduated cylinder and other liquid measuring tools, you'll notice a curved line at the top of the liquid. This is the meniscus. To properly read the volume of water, you need to read the measurement from the bottom of the meniscus. Density. Density is how much stuff is contained within a certain volume. Density of objects change as they go from a solid to a liquid to a gas. Generally, solid is the most dense, gas is the least. Water is the exception to this. We calculate density by dividing the mass over volume. So the SI unit for density is kilograms per cubic meter, but most scientists use grams per cubic meter or grams per milliliter. You can remember this formula for density by remembering this. If you're dense in love, you'll have a broken heart. So you write density equals and then draw a heart. Then draw a line through that heart. You have an M on top and a V on bottom for volume. So M for mass, V for volume. Density equals mass over volume. Density can be a lot of fun. Density allows things like this density column to exist. The different objects and liquids have different densities. Those with less density are on top, Those with more density are on bottom. If you think back to 6th grade, hot air and hot water rises because it's less dense than cold air and cold water. Time. The SI unit for time is seconds. There are 60 seconds in a minute and 60 minutes in an hour. This makes conversions a bit harder for the other units that are based on a system of 10, but we'll discuss that in the next video with conversions. You measure these units with a stopwatch. Temperature. Our last main measurement is temperature. The SI unit for temperature is Kelvin. It is great for many advanced scientific calculations because it doesn't have any negative units like Celsius or Fahrenheit. The spacing on units for Kelvin are the same as Celsius, just higher. 0 degrees Celsius, the freezing point of pure water, is 273.15 Kelvin, and 100 degrees Celsius, the boiling point of water, is 373.15 Kelvin. We measure temperature with a thermometer. There are lots of different types of thermometers. Some are digital, some use mercury, some use alcohol. Say two. Make sure that no one can use all the key vocabulary, know the SI base unit and tools for each of the 6 main measurements, know the difference between mass and weight, and can calculate density.